So now that we've visualized the print phrases method, let's do a deep dive into its implementation, which doesn't look a whole heck of a lot different from its visualization, but it's important to know that there's more to it than just the pictures. So here's the source code. You can find this in the SearchStreamGang abstract class, which is the root of all the implementation strategies in the code in my GitHub repository. So print phrases is going to use a stream that converts the list of lists of search results into a map that associates phrases found in the input with the works where they're found. It's a bit of a mouthful, but that's basically what it's doing. So let's take a look at the code. Here's print phrases. You can see it takes a list of search results as the parameter. That, of course, is the output from process stream that we looked at earlier. So process stream creates a list of search results. That's passed to print phrases. We convert that into a stream of lists of search results here. And then we call flat map. And as I mentioned before, flat map has this really cool property that it'll flatten a stream of lists into a stream of elements in the lists. That's one of the things it does. And it'll ignore any and all empty lists that happen to be in the stream. So anything that's empty is just ignored. So one of the interesting things about flat map, unlike map, is that depending on various characteristics, like what the input looks like, you may get more elements in the output stream than were in the input stream. You can get the same number of elements in the output stream that were in the input stream, and you can even get less elements in the output stream than were in the input stream. So again, depending on whether there's lots of empty elements, you might get less, you might get more. Depending on how big the lists are in our stream of lists, you may get more. So it really kind of depends on what the input looks like. But what's cool about flat map is it has these three different options, which is more flexible, of course, than what you get with good old map, where in map, the output stream has to contain the same number of elements as the input stream. So that's probably a good thing to remember for an upcoming quiz. What's the key difference between map and flat map? And the key difference, of course, would be that with flat map, you can have greater than, equal to, or less than the elements in the output stream than were in the input stream, whereas with map, it needs to be the same number. Like map, flat map also can be used to convert the type. So in this particular case, we're taking in a stream of lists of search results, and we get out a stream of search results. So the type is actually being changed there. So that's consistent with our earlier discussion. And now we have collect, triggers all the intermediate operations. And here in this case, we use a very interesting factor method called grouping by, which we talked about earlier, and now we're going to look at in a bit more detail. So what grouping by does is it takes three parameters. It takes a classifier, which is used to figure out what the keys and the values are. It takes a supplier, which indicates what kind of map you want to make. And then it takes something else called a downstream classifier. And so what happens is that we're going to use the getTitle method, which is a method reference defined in search results. That's what's going to be used to define what the keys are. So the stream comes in, we have a stream of search results. The keys are going to be the title of each of the search result objects, which will just return a string that's the title of the work. The kind of map we're going to make is controlled by this constructor reference, which is tree map : new, and that's passed in basically as a supplier. And so when grouping by needs to make the mutable result container that we're going to be storing things into, it uses a tree map. And what's significant about a tree map is it's going to sort the elements. So we're going to end up with things in sorted order. Irrespective of the order that they happen to come into the input, we're going to end up with output being sorted by the titles of the work. And then the third and final parameter to grouping by is something called this downstream collector. And what it does is it's going to essentially take the values that are corresponding to the indices and the search phrases and the indices, and it's going to go ahead and make essentially a list of search results. So we're going to have the keys be the strings, which are the titles, and then the downstream collector is going to do another classification round where it's going to go ahead and convert those things into lists of search results. And that's what we're going to end up printing out, which we saw earlier when we looked at the output from the print phrases method. So what we get back from all this is this map of strings to lists of search results, where each list of search result corresponds to phrases that were found for that particular title, for that particular work. And now what we're going to do, now that we've got this map, we're going to go ahead and use the for each method on the map. And for each key value pair on the map, this again uses some cool Java 8 features and the type deduction mechanisms that are built into Java, modern Java, Java 8 and beyond. We're going to take each key value pair and we're going to say, print out the title, like The Tragedy of Hamlet, Prince of Denmark, and then we're going to say contained, and then we're going to go ahead and print out each of the elements that are the phrases and where they appeared. So value.forEach is going to say for the list of search results, go ahead and print each of the search results, and that's how that's going to get displayed. And the search results : print method is something you can find in the search results.java file if you're so inclined to see how that code actually works. So what's neat about this is that this solution is very clean, very concise, spick and span, as I say here, and that's because we're just saying what we want to have done here. We're not really saying how to do it. The how to do it part is, of course, buried deep in the bowels of the streams framework with the flat map implementation and the grouping by factory method and collect and the various other things like the for each methods that we have here. So all that stuff is kind of hidden from you, and you can just sort of declaratively say what it is you want to have happen. Now, by the way, in practice, I probably also would not have created an intermediate local variable called map. I probably would have just said lists of results.stream.flatmap.collect.forEach. But just to make things a little bit more clear for the purposes of walking through each element in the code, I kind of split it up like this. Not that doing it the other way is wrong, per se. It just is not necessarily the way most Java programmers would write it in modern Java. So just kind of saying that this is more likely to be the way you would see the code in practice. You'd probably see it written more like this than written like that. So that's the end of the print phrases method. Hopefully now you've seen flat map in all of its glory. It's a really cool method. Learning to use it can be a little tricky, but it's worth figuring out how it works because it'll often save you a lot of effort when you start trying to get rid of too much structure in your streams. Because here we had this stream of lists of search results, some of which were empty. And dealing with that is cumbersome. So using flat map kind of flattened it all, and then we could just deal with a stream of search results, which was a lot cleaner and neater when we're all done.